Hi, today we are going to learn how to create your custom dataset even though you don't have any images. So let's run a demo and explain what we are going to do today. In this tutorial we're going to generate a full synthetic wildlife dataset using Python. So the goal is simple: create hundreds of high quality photorealistic images across multiple animal classes like lions, tigers, and more. So let's jump and see the result. You can see here the result. This is our target folder named wildlife dataset, and it contains several classes like bear, cheetah, elephant, giraffe. And let's dive into one of those folders, for example the giraffe folder. And if we will open one of the images, you can see a synthetic image with a giraffe, and this is another image, and that is another image. Each class will get its own labeled folder, so the dataset is ready for training right away. We will craft a strong text prompt for realism and use a negative prompt to avoid blur, artifacts, and weird anatomy. So if we go back to the code, you can see here for each of the classes we will describe the prompt that generate this class. This is, for example, for the lion, this is for tiger, this is for elephant, leopard, etc. The pipeline will run on GPU for speed with image size and inference step tuned for crisp details. As the code runs, we will save frame to the disk and briefly preview it so you can spot quality issues fast. So while running and generating the images, we will display a short preview of each of those images before it saves the disk. So by the end you will have a structured dataset you can plug into classification, detection, or segmentation models. Let's go back to our dataset. If we will grab for example the zebra, you can see all the zebra images as well. So this is 1, 2, so very cool and nice images of a zebra. So in order to do that, this will be the step number 3. We will start with step number 1, how to generate a simple image. Then we will jump to step number 2. We will generate an image, but we will learn how to twist the image and configure the image using parameters. And at last, step number 3 will be generating a full dataset. So let's start coding. Let's start with the installation. As you can see here, we will have a folder named how to create your custom dataset, and all the code will be here in this folder. I also add one installation file named install.txt. First of all, let's create a new Conda environment. Let's name it generate dataset. Of course, you can choose your own custom name, and it will be based on Python 3.11. And after that, we will activate this new environment. Of course, it will be run under Anaconda prompt. So first of all, open the Anaconda prompt and then run the 2 commands to create the environment and then activate it. And after that, we have to install a PyTorch. I decided to install PyTorch 2.5.1, and it's very important to choose the right CUDA version, and this command here is supported for CUDA 12.4. If you don't have a CUDA, you can also copy from the PyTorch website the installation command for a CPU if you don't have a GPU card. And if you have CUDA 11.x version, there is also a command for 11. version. Basically, if you go to the PyTorch website and choose the link for previous installation, you will come up with a list of all the previous PyTorch versions. And after you discover a 2.5.1, under that title you will find all the installation commands. So in my case, I choose to install for CUDA 12.4. You can run this command nvcc -- version and discover what is your GPU, what is your CUDA version if you have a GPU card. And after that, you have to install these Python libraries. Don't miss any of them, and you should also install the correct version. So this version for each of those Python libraries was tested along with Python 3.11 and with PyTorch 2.5.1. So don't install the last one, please install the specific version. And maybe it will work if you install the last version, but if you would like to come up with the same result, please install the same version for PyTorch and for those libraries. And in order that to run it on this new Conda environment, you should click Ctrl Shift and P, and it will come up with this menu, and then you should choose Select Interpreter, and you will get a list of all the Anaconda environment installed in your local machine. Let's look for the one that we just installed. It's named Generate Dataset, so we'll choose this one, Generate Dataset, and now we are ready to start the Python coding. So let's start and create our first Python file. This Python file will deal with a simple image generation, so let's call it step number 1, generate basic images. We import the stable diffusion pipeline from the diffuser library so we can turn text prompt to images. Let's also import Matplotlib and PyTorch. Next, this is the model identifier from Hugging Face Hub. I'm picking a style-friendly checkpoint that's called Dreamlike Diffusion 1. It's a very basic and simple one. We load the model into stable diffuser pipeline with half precision, float 16, and if this is your first run, it will download the weights to your local machine. After that, let's move the pipeline to CUDA so it runs on your GPU if it's available. If you don't have a GPU, you can skip this line. Now the first example will be this will be our first prompt, a brave young girl in a fantasy forest with story-rich details. This is the pipeline description, and after that we will call the pipeline with our prompt and take the first image from the output list, and then we will print the prompt and display the image. Let's run and see the result. So this is the download process and generating the first image, and this is our image, a very simple image using our prompt. Now let's take another example, a new prompt. Let's call it prompt number 2. All the prompts will be part of the video description. I will leave a link to the code that contains those prompts. And let's use another example. It will be prompt number 3. Once again, another prompt, generating images and display those images. After that, let's run it and see the results. So this is our first image. Let's see the second one. So this is our second image, and let's close it and it will generate the third image. Let's wait a few more seconds, and here it is. Let's enter the image. So we have 3 basic and simple images. Now let's continue to the second step, and now we would like to generate images with parameters. So we will send several parameters to the generation process, and we will learn how to create images with parameters. Similar as step number one, we will import stable diffusion pipeline so we can turn text prompt into images. Also, we will use torch and matplotlib. First of all, we will import our model checkpoints, and after that we will define our pipeline, very similar to our for the previous process. Now let's create an helper function that wraps generation plus display logic so we can do an A/B testing parameters quickly. It accepts the pipeline, a prompt string, and a params dictionary that will vary across the runs. So we will call the pipeline with our prompt and any extra parameter passed in the dictionary. The output is a list of images which will be visualized. And if we are generating more than one image, we will arrange them horizontally so we can compare one to each other. And if not, if we only generating one single image, we will display it, we will show it on a fresh figure, and after that we will tighten the layout to remove any extra padding around the images, so the result will be more clear. So after finalizing this function, we are ready to start with our first prompt. So our first prompt will be with no parameters. So we will pass an empty params dictionary to see the model defaults, and it's like establishing a baseline to help us to understand the impact of each parameter later. So let's run it and see the result. So this will be our first prompt. I believe you noticed that after the prompt we are running our generate image function. Now let's define a parameter named number inference step to control the number of denoising steps. Higher values often yield sharper and more detailed images at the cost of speed. So our first example contains only one parameter, number of inference step. Now let's continue to the second example. Next we will fix the output resolution, and we would like to get a consistency across a dataset. So we will define the height and the width that should match your training pipeline to avoid resizing artifacts. So we also would like that the height will be a bigger value than the width. So once again, it's the same parameter, 100 inference step, and we are adding the height and the width. Let's go to the third example. Now we ask for multiply samples per one prompt. So we would like to increase variety. So we have the number of inference steps, it will stay 100, and we are adding a number images per prompt, it will be 3. That means that we are expecting to see in this example 3 images as a result. And finally, we will add a negative prompt to discourage common artifacts. We would like to avoid those negative values. And once again, let's run the function and display the result. So let's run it. So this will be our first image, the one with no parameters. Now let's wait for the second one. So this is the second image, the one with the high value of inference step. This is the one that we are changing the dimensions of the image. Now we're expecting to see 3 images in one result. And the last one is with adding negative prompts for get better results. Great, so now let's continue to the third step. Let's move to step number 3, and in this step I will not do a freestyle coding. I'll leave the code in the video description as part of this tutorial, and I will just cover what we are seeing in this part, in the third part. Basically, it will generate a full data set for your needs for image classification. So first of all, let's start. It will be similar to our previous tutorial, but it will combine everything that we learned so far. So first, let's import all the libraries we need. We are using OS for handling folders, and CV2 for OpenCV saving and showing images, and Torch for the GPU acceleration, and stable diffusion as in the previous code from Diffuser for the actual image generation. And let's define the classes of animal we want to generate. So we would like to generate images for wild animals like lion, tiger, elephant, leopard, wolf, bear, giraffe, zebra, cheetah, and hippopotamus. And so these will be our classes. Basically, it will be our names of the subfolders that will contain the images. And here we will prepare the prompt for each class. This prompt describes exactly how the animals should look when we are generate, and the better the prompt, the better the image you will get. For example, for the lion, we define a majestic lion standing in a savanna, realistic, ultra detailed, sharp focus, photorealistic. So this will be the prompt. Of course, you can custom it for your needs. Then let's define a negative prompt, and this will tell the AI what to avoid. Here we are asking it to skip blurry, distort, or low quality feature. So now it's time to load our stable diffusion model. We will use the dreamlike diffusion model, which is great for photorealistic results. So this is our model. Next, we will load the pipeline from Hugging Face. We set Torch to float 16 to efficiency, and saves tensor for security. And after that, we will move the pipeline to the GPU so it will run faster. If you don't have a GPU card, you don't have to use this line. It's not relevant. It will run slower on a CPU. And after that, let's set up the folder where all images will be saved. Each animal will get its own subfolder inside the directory. Now let's define how many images. We will generate 100 images per an animal, and the image size is set to 640 by 640 pixel. We also define how many inference steps we want. More step usually means better quality. We will define it here. The number of steps, we'll learn about it in step number 2. Now this is the final loop. Let's loop through each animal and generate the images. We will first of all create the subfolder for this animal if it doesn't already exist, and for each animal we will generate the defined number of images using the range function. We will print the progress to the console so we know how far along we are. We will run the diffusion pipeline with the prompt. Diffusion pipeline with the prompt, here it is, and we will grab the generated image. We will convert the generated image into an OpenCV format, BGR instead of RGB, and we will save the generated image in the animals folder with a number file name. So each image will have a different number in part of the file name. And we also display on runtime, we will show the image on the screen for a quick preview, and it will stay open for 1 second and then close automatically. And basically that's it. So let's run it and see the result. So let's wait a few more seconds for the first image, and this is our first lion. Hope you saw it. Let's wait a few more seconds for the second image, and this is the second lion. So basically this is the progress, and I already run it through all the animals. So I generated hundreds of images, and if we stop the running here and let's see the result, I will grab it here, and here you can see there is a bear, cheetah, elephant, giraffe, hippopotam, leopard. Let's for example go inside the giraffe subfolder. Let's make it bigger, and you can see the generated image. 1 second, so let's move it to here. So this is one giraffe, this is giraffe number 1, and giraffe number 2, giraffe number 3. So very good quality images of giraffe. If we will close it, let's go back to the subfolder and let's look for the cheetah. Let's open the cheetah images, and it's basically the same concept. So each one of those images is a cheetah image. So this is how you can generate your own custom dataset in any subject matter area, and after that you can run a classification model, so you will have a pre-trained model for your custom images even though you don't have a dataset. So thank you very much. I hope you enjoyed this tutorial as well. You're most welcome to subscribe my channel. Bye bye.